Hello students, in our series of crash course, today we'll study analytical chemistry. This is day 40 of our crash course. This is disclaimer. So today we are going to learn about confirmatory test for second group radicals, which include Pb2 plus and Cu2 plus, which means lead ions and copper ions. After that we will study confirmatory test for third group radicals, which include Fe3 plus and Al3 plus. After that, we will study confirmatory test for fourth group radicals, which include zinc and nickel ions, Zn2 plus and Ni2 plus, followed by confirmatory test for fifth group radicals like barium, calcium and strontium ions. Confirmatory test for sixth group radicals like magnesium ions, we will also study about that. After that, we will learn about methods of detection of extra element in organic compounds. And finally, we will study about the method of detection of some functional groups. So first, let's discuss the confirmatory test for second group radicals. When hydrogen sulfide gas is passed through solution containing group 2 cations, these cations react to form insoluble sulfide precipitate. So we studied in our previous lecture that on the basis of solubility product and reagent use, the basic radical are classified into 6 groups and they all have different group reagent. So for group 2, what is the group reagent? It is H2S in the presence of dilute HCl. So when hydrogen sulfide gas is passed through a solution containing group 2 cations, these cations react to form insoluble sulfide precipitates. So let's see how are we going to identify second group radicals. Here are the methods of identification of copper 2 plus and Pb2 plus. Cu2 plus react with dilute HNO3 and excess conc NH4OH, that is ammonium hydroxide, to form a deep blue solution due to the formation of the complex ion CuNH3 whole 4 2 plus. So copper ions react with nitric acid and excess of conc NH4OH and it gives blue color. And this blue color is due to the formation of which complex ion? CuNH3 whole 4 2 plus. While with potassium ferrocyanide, when copper ions react with potassium ferrocyanide, it forms a reddish brown precipitate. And this reddish brown precipitate is of which compound? It is of Cu2FeCN whole 6. On the other hand, for Pb2 plus, when Pb2 plus react with alcohol and conc H2SO4, that is conc sulfuric acid, it produces a white precipitate of lead sulfate, PbSO4. And when lead ions Pb2 plus react with potassium chromate solution, it gives yellow precipitate. Yellow precipitate of which compound? Lead chromate, PbCrO4. So these reactions are used in qualitative analysis to identify these cations based on their characteristic precipitate and color changes. So when dealing with second group cations, passing hydrogen sulfide H2S in a hot solution slowly helps in forming more granular and filterable precipitate because higher temperature increase the solubility of metal sulfide, which allows excess H2S to escape and promoting the formation of larger distinct crystals. This makes the precipitate easier to filter and purify, which is crucial for qualitative analysis. So for second group cations, H2S must be passed in hot solution slowly to get more granular and easily filterable precipitate. Now we are going to discuss the chemical equations, the chemical reactions involved in the conformation of Cu2 plus and Pb2 plus ions. So let's begin by looking at the key reactions that help in identifying these ions. So first we'll see the reactions for copper ions, Cu2 plus. So here is the chemical reaction given. So this chemical equation shows the reaction between copper sulfide CuS and nitric acid HNO3. In this reaction, nitric acid oxidizes sulfide to sulfur. The sulfide ion present in copper sulfide CuS, so nitric acid oxidizes that sulfide ions to sulfur, which precipitates as a solid, which is represented by the down arrow. And the copper forms copper nitrate, and nitrogen monoxide gas is also produced because nitric acid is acting as oxidizing agent here. It oxidizes sulfide to sulfur and itself gets reduced from HNO3 to NO. In HNO3, the oxidation state of nitrogen is +5, but in NO it is +2. So it is getting reduced. So copper forms copper nitrate and nitrogen monoxide is also produced during this reaction. Water is also formed as a byproduct. Then copper 2 nitrate reacts with ammonium hydroxide to form cupric hydroxide. So the copper nitrate, which is formed in the above equation, it further reacts with ammonium hydroxide NH4OH to form cupric hydroxide, which is a blue precipitate, and ammonium nitrate. Ammonium nitrate is also formed in this reaction. So when copper nitrate solution is mixed with ammonium hydroxide solution, a blue solid cupric hydroxide forms and ammonium nitrate remains in solution. This is a double displacement reaction where the cations and anions are exchanged between the ionic compounds. When copper 2 hydroxide reacts with ammonium nitrate, that is NH4NO3, and ammonium hydroxide NH4OH, it forms a T blue complex of tetraamine copper 2 nitrate along with water. So when copper hydroxide CuOH whole twice react with ammonium nitrate NH4NO3 and ammonium hydroxide NH4OH, what is formed? It forms T blue complex of tetraamine copper 2 nitrate. Its chemical formula is CuNH3 whole 4 NO3 whole twice, and water is also formed as a byproduct. So this reaction shows how copper hydroxide dissolves in ammonia to form a soluble complex ion, which demonstrate the amphoteric nature of copper hydroxide. So amphoteric means the substances, the compounds which can react with both acid and base. So here this reaction explains the amphoteric nature of copper hydroxide. When copper 2 nitrate reacts with potassium ferrocyanide, a reddish brown precipitate of cupric ferrocyanide forms. So when copper nitrate reacts with potassium ferrocyanide K4FeCN6, it forms cupric ferrocyanide Cu2FeCN6. It is a reddish brown precipitate. So this reaction also demonstrates a double displacement process where copper ions combine with the ferrocyanide ion while potassium and nitrate ions remain in solution as potassium nitrate. The precipitate indicates that a new compound has formed. And what is the precipitate here? It is a cupric ferrocyanide compound which is reddish brown in color. Cu2FeCN6. So these are the confirmatory tests for detection of copper ions in the sample. Now moving on, let's see the reactions for the lead ion Pb2+. So here is the reaction given. This reaction shows the reaction between lead sulfide PbS and nitric acid HNO3, where black PbS, what is the color of lead sulfide? It is black in color. So PbS react with HNO3 to form lead nitrate, PbNO3 whole twice. Nitrogen monoxide, that is nitric oxide, NO, water and sulfur as well. In this reaction, nitric acid acts as an oxidizing agent and oxidizes S2 minus to sulfur, that is sulfide ion to sulfur, and while nitric acid itself undergoes reduction and it forms NO, nitric oxide, or we can say nitrogen monoxide. The sulfur precipitates out as a solid, which is represented by down arrow, and NO gas evolves, which is represented by up arrow. When something is precipitating, we use down arrow, and when any gas is evolving, anything is escaping, we use up arrow. And now, then lead nitrate reacts with potassium chromate in aqueous solution to form insoluble lead chromate that have yellow precipitate. So lead chromate PbCrO4 is yellow in color. It separates out as yellow precipitate, and soluble potassium nitrate is also formed during this reaction. So lead nitrate PbNO3 whole twice react with potassium chromate K2CrO4 to form yellow precipitate of which compound? Lead chromate PbCrO4, and along with it potassium nitrate is also formed. So these are the reactions involved in the conformity test for lead ion. Now let's discuss the conformity test for third group radicals like iron and aluminium. So third group radicals include iron ions Fe3 plus and aluminium ions Al3 plus. So what is the group reagent for the third group radicals? So it is NH4Cl plus NH4OH, that is ammonium chloride plus ammonium hydroxide. So these third group radicals are precipitated by the addition of ammonium chloride and ammonium hydroxide. Both Fe3 plus and Al3 plus form hydroxide when precipitated with ammonium chloride and ammonium hydroxide. Now let's see how we identify these third group radicals. So when testing for Fe3 plus and Al3 plus ions, Fe3 plus forms a red-brown precipitate of FeOH whole thrice, while uh, aluminium, it reacts with NH4Cl and NH4OH to form white gelatinous precipitate of AlOH whole thrice. And this red-brown precipitate of FeOH whole thrice is soluble in dilute HCl, while AlOH whole thrice is soluble in NaOH, not in HCl. Fe3 plus, that is ferric ions, react with K4FeCN whole 6 to form a blue precipitate. So when Fe3 plus react with K4FeCN whole 6, it forms blue color precipitate. And when Fe3 plus react with KSCN solution, it gives a blood red coloration. Now we'll discuss the reactions for Al3 plus. So the leg test for aluminium ion Al3 plus involves dissolving the precipitate, the white gelatinous precipitate, in NaOH and then adding HCl and blue litmus, followed by NH4OH to produce a blue lake. And in the charcoal cavity cobalt nitrate test, aluminium ions Al3 plus gives a blue mass. So aluminium ions in the charcoal cavity test forms a blue mass with cobalt nitrate. Now we'll see the chemical equations that are significant in the conformation of iron 3 and aluminium 3 ions. These equations are used to identify the presence of these ions through observable reactions typically involving the color changes or precipitation. The equation helps in understanding the behavior of these metal ions in solution and their interaction with various reagents. So first we'll see the reactions for Fe3 plus ions. So here we have the reaction given. This reaction shows iron 3 hydroxide reacting with hydrochloric acid, that is HCl, to form iron chloride FeCl3. The oxidation state of Fe in FeCl3 is +3, and along with it water is also formed. So this is a neutralization reaction where a base, that is ferric hydroxide FeOH whole thrice, react with an acid HCl to produce a salt FeCl3 and water. So what is neutralization reaction? Here an acid and a base react with each other to form salt and water. Here the base is ferric hydroxide FeOH whole thrice and acid is HCl. They both react to form salt FeCl3. Along with it water is also produced. So this is an example of a double displacement reaction where the cations and anions of the reactant exchange places. And when iron 3 chloride react with potassium ferrocyanide, a deep blue precipitate called Prussian blue is formed. This reaction is a classic example of precipitation reaction where Fe3 plus ions from ferric chloride FeCl3 react with FeCN6 4 minus ions from K4FeCN6, that is potassium ferrocyanide, to form an insoluble compound Fe4FeCN6 3. This is a Prussian blue precipitate. This is a very important compound. This is Prussian blue precipitate and it is the chemical formula of this Prussian blue Fe4FeCN6 whole 3. Here the outer iron has oxidation state of +3 while the iron present inside the complex has oxidation state of +2. So this compound is widely used in ink as a pigment and the reaction is often used in qualitative analysis to detect Fe3 plus ions. And along with this Prussian blue precipitate, 12 molecules of KCl is also formed. If potassium ferrocyanide is added in excess, then a product of composition KFeFeCN6 is formed. This tends to form a colloidal solution, which is soluble Prussian blue, and it cannot be filtered. So, on passing excess potassium ferrocyanide, FeCl3 forms soluble Prussian blue, that is colloidal solution, and this cannot be filtered. What is the formula of this colloidal Prussian blue? It is KFeFeCN6. So now we have the another conformity test for iron. When Fe3 plus react with thiocyanide ions SCN minus, it forms a blood red precipitate of FeSCN2 plus. So this is blood red in color, FeCN2 plus, and it is formed when iron ions, that is ferric ions, react with thiocyanide ions. And this is soluble in water. It forms blood red coloration. This ion FeSCN whole FeSCN, and the power is, the charge is 2 plus. Now moving on, we will see the reactions for Al3 plus ions. When aluminum hydroxide AlOH whole thrice, a gelatinous white precipitate, reacts with excess sodium hydroxide NaOH, it dissolves to form sodium aluminate NaAlO2. What is the formula of sodium aluminate? It is NaAlO2 in solution, and water is also formed. So this reaction demonstrates the amphoteric nature of aluminum hydroxide. Aluminum hydroxide is also amphoteric in nature. It means it reacts with both acid and base. So aluminum hydroxide can act as an acid and react with strong base like NaOH. This concept is very important in chemistry, especially in qualitative analysis where hydroxides are used to identify metal ion. So when aluminum hydroxide reacts with NaOH, it forms sodium aluminate NaAlO2. This reaction shows the neutralization reaction of aluminum hydroxide, which is by hydrochloric acid and acid, forming aluminum chloride in solution and water. So here aluminum hydroxide is acting as base and it's reacting with HCl, which is an acid, to form salt and water. Salt is aluminum chloride, AlCl3. So when a base reacts with an acid, they utilize each other to form a salt and water. In this case, aluminum hydroxide, that is AlOH whole thrice, react with hydrochloric acid HCl to produce aluminum chloride AlCl3, which is soluble salt and water. When ammonium hydroxide is added to a solution containing aluminum ions, it reacts to form a white precipitate of aluminum hydroxide, AlOH whole thrice. This precipitate has the ability to absorb the blue coloring matter of litmus, forming a complex that remains suspended in the solution, creating a blue lake. AlOH whole thrice absorbs blue coloring matter of litmus to form a complex named lake. Thus, a blue mass floating in the colorless solution is obtained. So, this is our lake test. Addition of ammonium hydroxide precipitate ALS aluminum hydroxide, and this aluminum hydroxide absorbs blue coloring matter of litmus to form a complex named lake. Thus, a blue mass floating in the colorless solution is obtained. Now, let's discuss the conformity test for fourth group radicals, which include zinc ions and nickel ions. These are precipitated as sulfide in ammoniacal medium. So, what is the group reagent for this fourth group radical? It is H2S in the presence of NH4OH. Now, let's see how we will identify fourth group radicals. When testing for Zn2 plus and Ni2 plus ion, that is zinc ions and nickel ions, using different reagent. In cobalt nitrate test, Zn2 plus gives green mass. Zn2 plus forms a dirty white precipitate ZnS with H2S, which dissolves in dilute HCl and then forms a white precipitate with NaOH that dissolves in excess of NaOH. And it also forms a white precipitate. Zinc ion forms white precipitate with potassium ferrocyanide solution. Nickel ions, on the other hand, forms a black precipitate NiS with H2S, which dissolve in aqua regia. Ni2 plus gives a scarlet red precipitate with dimethyl DMG in NH4OH, helping us to distinguish it from Zn2 plus. So, Ni2 plus gives black precipitate with H2S, while Zn2 plus gives dirty white precipitate with H2S. The black precipitate of nickel sulfide NiS is soluble in aqua regia. What is aqua regia? It is a mixture of nitric acid and hydrochloric acid. It contains 3 parts of HCl and 1 part of HNO3. And this Ni2 plus react with TMG and excess of NH4OH to give a scarlet red precipitate. This reaction is very important for the confirmatory test of Ni2 plus. So this is how we can distinguish between Zn2 plus and Ni2 plus. So cations of group 4 are precipitated as sulfide using H2S. But we have to take a precaution here. The precaution is that while doing this, while precipitating group 4 radicals with H2S, H2O should not be passed continuously. Otherwise, NiS, that is nickel sulfide, becomes colloidal and does not filter properly. So, in fourth group, H2O should not be passed continuously. Otherwise, NiS, nickel sulfide, turns in colloidal state. So, let's see some chemical equations which play an important role while conformation of Zn2 plus and Ni2 plus ions. So first we'll talk about the reactions of zinc ions, Zn2+. Zinc sulfide, ZnS, is soluble in dilute hydrochloric acid, HCl, and it forms zinc chloride and produces H2S gas. The resulting zinc chloride, ZnCl2, gives zinc hydroxide, ZnOH whole twice, when sodium hydroxide is added in limited amount. A white precipitate of zinc hydroxide appears in this step. So, when zinc chloride reacts with a limited amount of sodium hydroxide, it forms zinc hydroxide. Now, zinc hydroxide is amphoteric in nature. So, it dissolves in excess sodium hydroxide, forming sodium zincate. This compound is also very important, sodium zincate. Its chemical formula is Na2ZnO2. So, when zinc hydroxide is passed through excess of NaOH, that is sodium hydroxide, forms sodium zincate, Na2ZnO2. So here zinc hydroxide is showing its amphoteric nature by reacting with a base. The conformity test for zinc ion is performed using ferrocyanide ion, FeCN6 4-. Zinc ions react with potassium or sodium ferrocyanide to produce white precipitate of zinc ferrocyanide. The formation of this white precipitate of zinc ferrocyanide Zn2 FeCN6 confirms the presence of zinc ion in the given solution. Now let's see the reactions for Ni2 plus ions. Nickel sulfide NiS is black in color and it is insoluble in dilute acids. Therefore, it is dissolved in aqua regia for further test. Aqua regia is very corrosive. It is highly corrosive. It is a mixture of concentrated nitric acid and hydrochloric acid. It contains 3 parts of hydrochloric acid and 1 part of nitric acid. So, zinc nickel sulfide dissolve in aqua regia according to the given reaction. In this reaction, the black nickel sulfide dissolves, forming nickel chloride solution with sulfur separating out and nitric oxide gas being released. In this reaction, nitrate ions NO3- acts as strong oxidizing agent, oxidizing sulfur in NiS to elemental sulfur S, while nitric acid is itself reduced to nitric oxide. So, nitrate ions acts as oxidizing agent here. It oxidizes sulfide ions present in NiS to elemental sulfur, while itself it undergoes reduction to nitrogen monoxide or nitric oxide NO. Here, hydrochloric acid provides chloride ions which forms complexes with Ni2 plus ions, which help in the dissolution process. So this reaction demonstrates redox chemistry, where NiS, nickel sulfide, is oxidized and nitrate is reduced. What is redox? The redox reaction, it involves the simultaneous oxidation and reduction reaction. So this is an example. Here NiS is oxidized and nitrate is reduced. So this reaction have practical applications in metal extraction and purification process also. So the most important confirmatory test for Ni2 plus is the dimethyl glyoxime test, that is DMG test. This is the most important confirmatory test for nickel ions. When nickel ion solution is treated with dimethyl glyoxime in the presence of an ammonium hydroxide, that is NH4OH, a scarlet red precipitate of nickel dimethyl glyoximate is formed. So here is the structure of nickel dimethyl glyoximate. So we can see this is a square planar complex where the central metal ion is Ni2 plus. So this complex contains DMG ligand. 2 DMG ligands are present here and each DMG ligand acts as a bidendant ligand. It donates electron from its nitrogen atoms, as we can see it forming bond with Ni2 plus. So this is the structure of covalent structure of nickel dimethyl glyoximate, and it is scarlet red in color. So appearance of this red precipitate in the reaction in the solution, it confirms the presence of nickel ions in the given salt. Now moving on to fifth group radicals. Fifth group cations, that is barium, calcium and strontium ions, are precipitated by adding ammonium chloride, excess ammonium hydroxide, followed by adding solid ammonium carbonate to the original solution. So what is the group reagent for fifth group radical? It is ammonium carbonate in the presence of ammonium chloride and excess of ammonium hydroxide. So these fifth group radicals are precipitated by adding a small amount of solid NH4Cl and an excess of NH4OH solution, followed by solid NH4 whole twice CO, that is ammonium carbonate. And they are precipitated in form of carbonates, not sulfide, not hydroxide. They are precipitated in form of carbonates, and these precipitates are soluble in acetic acid, CH3COOH. Now let's see how we'll identify group 5 radicals. So when testing for barium Ba2 plus and calcium Ca2 plus ions, both form white precipitate and they are precipitated as carbonates, barium carbonate, calcium carbonate. Barium ion react with potassium chromate, K2CrO4, to form a yellow precipitate of barium chromate, while calcium Ca2 plus ions react with ammonium oxalate to form a white precipitate of calcium oxalate. Additionally, we have a flame test. Barium imparts a green color to the flame in flame test, whereas calcium gives a brick red color in flame, which help us to distinguish between the barium and calcium ions. Now we will see the chemical equations that are significant and are involved in the confirmatory test of barium and calcium ions. So first we will see the reactions for barium ions, Ba2+. When barium chloride reacts with ammonium carbonate, a white precipitate of barium carbonate forms, which indicates a double displacement reaction where the cations and anions exchange partners. Barium ions Ba2 plus from barium chloride BaCl2 combine with the carbonate ions CO3 2 minus from ammonium carbonate to form insoluble barium carbonate BaCO3, which settle out of the solution as a white precipitate, while the ammonium ions NH4 plus and chloride ion Cl minus remain in solution as soluble ammonium chloride NH4Cl. This reaction is commonly used in qualitative analysis to identify the presence of carbonate ions, as the formation of a white precipitate with barium chloride is a characteristic test for carbonates. This reaction here presented shows barium carbonate BaCO3 reacting with acetic acid CH3COOH to form barium acetate CH3COO whole twice Ba. Along with it, water and carbon dioxide gas is also formed. So the carbonate ion CO3 2 minus from barium carbonate reacts with hydrogen ions that are produced from, that is associated from CH3COOH to produce carbonic acid H2CO3, and this carbonic acid H2CO3 decomposes into water and carbon dioxide gas. Barium acetate is a soluble as salt, so it remains in solution. When barium ethanoate or barium acetate CH3COO whole twice Ba react with potassium chromate, a yellow precipitate of barium chromate forms BaCrO4, which indicates a double displacement reaction where barium ions from barium ethanoate combine with chromate ions from potassium chromate K2CrO4 to form an insoluble salt which is barium chromate BaCrO4, while potassium ions and ethanoate ions remain in solution as potassium ethanoate. This reaction is commonly used in qualitative analysis to identify barium ions, as the yellow precipitate is a clear indicator of their presence. So, the formation of yellow precipitate of BaCrO4 barium chromate clearly indicates the presence of barium ions in salt. BaCl2 barium chloride is very volatile and it provides apple green color to the flame in flame test. And now let's see the reactions for calcium ion, that is Ca2 plus ions. Calcium chloride react with ammonium carbonate to form a white precipitate of calcium carbonate CaCO3, which is a common example of a double displacement reaction. The calcium ion form calcium chloride CaCl2 combined with carbonate ion from ammonium carbonate NH4 whole twice CO3 to form insoluble calcium carbonate CaCO3, while the ammonium and chloride ions remain in solution as soluble ammonium chloride NH4Cl. This reaction is often used in laboratories to prepare calcium carbonate, which has practical applications in industries like construction and pharmaceuticals. So, the calcium carbonate CaCO3 react with acetic acid CH3COOH to produce calcium acetate CH3COO whole twice Ca. Along with it, water and carbon dioxide gas is also released. The calcium acetate formed in the above reaction react with ammonium oxalate NH4 whole twice C2O2 to form calcium oxalate. The chemical formula of calcium oxalate is CaC2O4. Calcium oxalate is insoluble in water, so it forms a solid white precipitate, while the ammonium salt remains in solution. This is a double displacement reaction where the cations and anions exchange partners, so the calcium acetate and the ammonium oxalate exchange their cations and anions to form calcium oxalate and ammonium acetate or ammonium ethanoate. Now let's see the reaction of strontium ions Sr2 plus. So strontium ion react with carbonate ions to form solid strontium carbonate SrCO3. SrCO3 is strontium carbonate, and this strontium carbonate formed is insoluble in water. So this reaction shows the formation of precipitate when strontium ions combine with carbonate ions. Strontium carbonate SrCO3 react with acetic acid to form strontium acetate SrCO3 COO whole twice, and water and carbon dioxide gas is also formed. So we can say that the carbonate ion CO3 2 minus from SrCO3 react with the hydrogen ions from acetic acid to produce water and carbon dioxide gas, while the strontium ion Sr2 plus combine with the acetate ion CH3COO minus to form the soluble salt strontium acetate. Now we learn about the confirmatory test for sixth group radical. So let's see how we will confirm the presence of magnesium ion, because the sixth group contain which ion? Magnesium ion. So when magnesium ions are treated with little NH4Cl, that is ammonium chloride, excess NH4OH and sodium hydrogen phosphate solution, they produce a white crystalline precipitate. This white precipitate is magnesium ammonium phosphate. So what is the group reagent for 6th group? It is sodium hydrogen phosphate Na2HPO4. And when magnesium ions are treated with dilute HCl and few drops of magnesium reagent, a blue color or blue precipitate is formed. This indicates the presence of magnesium ions. Now let's see the chemical equations involved in the conformation of Mg2+. The major reaction for the conformation of magnesium ion is magnesium ions react with hydrogen phosphate ion, that is HbO4 2- and ammonium ions NH4+. It forms magnesium ammonium phosphate MgNH4PO4, and it has a white crystalline precipitate. Magnesium ammonium phosphate is white in color and it separates out white crystalline precipitate. And formation of this white crystalline precipitate confirms the presence of magnesium ions. So till now we discussed the confirmatory test for the basic radicals. There were 6 groups involved in that, starting from the 0. Now we will learn about the methods of detection of extra element in organic compound. So if you have understood the confirmatory test for the basic radicals, send a thumbs up in the chat box. So detection of extra element in organic compound. Presence of extra elements like nitrogen, sulfur and halogen represented by X in an organic compound is identified by Lassaian test. Lassaian test is used to detect the presence of certain elements like nitrogen, sulfur and halogens in organic compound. And how this test is performed? This is done by fusing the compound with sodium metal to form a sodium extract, also called Lassaian extract, which allows the element to be identified through subsequent chemical reactions. The fusion process converts covalent bonds into ionic bonds, making the elements easier to detect. Now let's see how we will detect the presence of nitrogen in organic compound using Lassaian's test. When an organic compound is fused with metal, sodium metal, the covalently bonded nitrogen in the compound is converted into ionic form, that is sodium cyanide. So when organic compound is fused with sodium metal, the covalent bonded nitrogen in the organic compound gets converted to ionic form, that is in NaCN, sodium cyanide. To the extract, to the Lassaian's extract, freshly prepared FeSO4, that is ferrous sulfate, and NaOH are added, and then this solution that is formed is boiled and cooled. The resultant solution is then acidified with dilute H2SO4 and a few drops of FeCl3 are added. It results in the formation of Prussian blue or greenish blue color, which confirms the presence of nitrogen. So if we observe the Prussian blue color or greenish blue precipitate, then we know that the organic compound contains nitrogen as an extra element. Now let's understand the reactions taking place during the detection of nitrogen. So first, ferrous sulfate react with sodium hydroxide. This reaction shows how ferrous sulfate reacts with sodium hydroxide to form ferrous hydroxide, which precipitates out of the solution, and sodium sulfate is also formed during this reaction. Ferrous sulfate is a salt of ferrous ion, Fe2+, and when it reacts with strong base like NaOH, a double displacement reaction occurs. The ferrous ions combine with hydroxide ions to form insoluble ferrous hydroxide, FeOH whole twice, which settles at the bottom as a precipitate, while sodium ions and sulfate ions remain in solution as sodium sulfate, Na2SO4. This FeOH whole twice that is formed in this reaction is needed for the subsequent reactions. Now, the formed ferrous hydroxide FeOH whole twice react with NaCN, that is a sodium extract. This reaction shows the formation of sodium ferrocyanide Na4FeCN6 from ferrous hydroxide FeOH whole twice in the presence of sodium cyanide NaCN. Sodium cyanide acts as a complexing agent here. It reacts with Fe2, that is ferrous hydroxide, where the iron is present in +2 oxidation state. So it reacts with iron 2 hydroxide to form a stable complex ion FeCN6 4 minus, which is then surrounded by sodium ions to form the final product, sodium ferricyanide. What is the final product? Sodium ferricyanide. Sodium hydroxide is also produced as a byproduct. Now in the next step, sodium ferrocyanide react with ferric chloride. This reaction shows the formation of ferric ferrocyanide, also known as Prussian blue. So when sodium ferrocyanide react with, that is Na4 FeCN6 react with ferric chloride FeCl3, then it forms ferric ferrocyanide Fe4 FeCN6 3. It contains the ferrocyanide ion FeCN6, and along with it 12 molecules of NaCl is also formed. This Fe4 FeCN6 thrice is insoluble and precipitates out as a deep blue solid Prussian blue. This reaction is an example of precipitation reaction, and this is used in qualitative analysis to detect Fe3 plus ion, as the formation of Prussian blue is a characteristic test for ferric salt. If S is also present, that is sulfur is also present along with nitrogen in the test for nitrogen, blood red color is obtained instead of blue or green. Because if the organic compound contains both nitrogen and sulfur, sodium fusion does not produce NaCN. Instead, it produces sodium thiocyanate NaSCN. And when it is treated with ferric chloride, blood red color is produced due to the formation of ferric sulfocyanide, which is blood red in color, water soluble chemical compound. This reaction here shows the formation of ferric sulfocyanide, which is a red colored compound. It forms when sodium thiocyanate NaSCN react with ferric chloride FeCl3. In this reaction, Fe3 plus ions from FeCl3 combine with thiocyanate ions from NaSCN to form the complex ion FeSCN whole thrice 3 minus, which gives the compound its characteristic red color. Sodium chloride NaCl is a byproduct formed from the exchange of sodium and iron ions. Now let's see how we detect the presence of sulfur in organic compound using Lassane's test when nitrogen is not present. So when an organic compound is fused with sodium, sulfur present in the compound is converted into sodium sulfide Na2S. This Na2S sodium sulfide in the Lassane's test is tested by two methods. It can be detected by the following two methods. First, we have sodium nitroprusside test. In this test, sodium sulfide reacts with sodium nitroprusside to form sodium thionitroprusside, which gives a violet color. Appearance of this violet color confirms the presence of sulfur. So Na2S combined with sodium nitroprusside Na2FeCN5NO to form sodium thionitroprusside. Its chemical formula is Na4FeCN5NOS. It is violet in color. Next, we have lead acid test for detection of sulfur. In this test, sodium sulfide Na2S react with lead acetate CS3COO whole twice Pb to form a black precipitate of lead sulfide PbS. Along with it, sodium acetate CS3COO Na is also formed. This is a double displacement reaction where the sulfide ion S2 minus from sodium sulfide combined with the lead ion Pp2 plus from lead acetate to form an insoluble salt PbS, which precipitates out of the solution. So formation of black precipitate of PBS, lead sulfide, confirms the presence of sulfur in the organic compound. Now let's see how we will detect the presence of halogen element such as chlorine, bromine and iodine in organic compound using Lascience extract. When an organic compound is fused with sodium metal, halogen present in the organic compound forms sodium halides. To detect halogen, two common tests are used. First, HeNO3 test, that is silver nitrate test, and second, Bilstein test. So, first we'll see silver nitrate test, that is HeNO3 test. So, in HeNO3 test, Lascience extract is first treated with concentrated nitric acid, that is conc HNO3. This mixture is boiled for 1 or 2 minutes and then cooled. After cooling, silver nitrate solution is added to it. The color and solubility of precipitate indicates which halogen is present. So, if a white curdy precipitate forms that are soluble in ammonium hydroxide NH4OH, it indicates the presence of chloride ions, Cl- ion. This is because chloride ions react with silver nitrate HeNO3 to form silver chloride HCl precipitate. However, this HCl is soluble in excess NH4OH, that is ammonium hydroxide, due to the formation of a complex ion AgNH3 whole twice plus, which is stable and soluble in water. So this reaction here shows the precipitation reaction where the sodium chloride NaCl reacts with silver nitrate HNO3 to form silver chloride HCl, which is insoluble and precipitate out as a white solid. And sodium nitrate NaNO3, which remains in solution, is also formed. In this case, in this reaction, HCl is a common white precipitate which is used in qualitative analysis to detect chloride ions. This reaction shows how silver chloride, that is HCl, which is insoluble in water, dissolves in ammonium hydroxide NH4OH and forms AgNH3 whole twice Cl, which is a soluble complex ion, and along with it water is also formed as a byproduct. So if we perform the HNO3 test with the halogen, that is the sodium halide Lascience extract, and it results in the formation of white curdy precipitate which is soluble in NH4OH. It indicates that this reaction indicates the presence of chloride ion as halogen in the organic compound. Now, if the formation of pale yellow precipitate occurs that is partially soluble in NH4OH, it indicates the presence of bromide ion in the organic compound. So, in this reaction, sodium bromide NaBr reacts with silver nitrate HeNO3 to form a pale yellow precipitate of silver bromide AgBr and sodium nitrate NaNO3 in solution. So, first the Br, which is present in the organic compound, will react it will react with the sodium metal to form NaBr, NaX, that is sodium bromide. And this will react with silver nitrate AgNO3 to form pale yellow precipitate of silver bromide AgBr, and along with it sodium nitrate NaNO3 is also formed. This is a double displacement reaction where the cations Na plus and Ag plus and anions Br minus and NO3 minus exchange their partners. Silver bromide is insoluble in water, hence it forms a precipitate, while sodium nitrate remains dissolved. This reaction is commonly used in qualitative analysis to detect the presence of bromide ions, as the characteristic pale yellow precipitate helps in identifying the bromide ion in the sample. Now the next reaction shows how silver bromide AgBr, which is an insoluble compound, dissolves in ammonia NH4OH to form a soluble complex ion AgNH3 whole twice Br. Along with it, water is also formed. So this pale yellow precipitate is partially soluble in NH4OH because it forms a complex in aqueous solution of ammonia, that is NH4OH. This complex is AgNH3 whole twice Br. And if a yellow precipitate is formed that does not dissolve in ammonium hydroxide NH4OH, it is insoluble in NH4OH, it indicates the presence of iodide ion. So iodine is present as halogen in organic compound. This is because iodide ions react with silver nitrate AgNO3 to form silver iodide AgI, which is yellow insoluble salt. Since AgI, silver iodide, is not soluble in NH4OH, this test is a reliable qualitative method to detect iodide ions, I minus ions. This reaction here shows the formation of yellow precipitate of silver iodide AgI when sodium iodide NaI reacts with silver nitrate AgNO3. Now next we have Bilston test. It is a chemical test which is used to detect the presence of halogens, particularly chlorine, bromine or iodine in organic compound. In this test, a copper wire is heated in a Bunsen burner flame until it turns red hot. Then a small amount of compound is brought into contact with the hot wire. So when a copper wire is dipped in organic compound is heated, it produces a greenish or bluish green flame, which indicates the presence of halogens like chlorine, bromine or iodine. But several other non-halogen compounds or halogen-free compounds like pyridine, purines, urea and thiourea can also give green flame, which makes this test unreliable for confirming halogen. However, production of no green or no blue color confirms the absence of halogen. So more than presence of halogen, this test is reliable for detecting the absence of halogen organic compound. Therefore, this test is confirmatory to show the absence of halogen rather than their presence. And this Belston test is not given by fluorine because copper fluoride is not volatile. Now we will study the detection of functional groups in organic compound. There are various methods available for identifying the presence of functional group in a compound. These methods typically involve chemical test or instrumental techniques that help to determine the specific type of functional group based on characteristic reactions or spectral data. So let's first see the test for carboxylic acid group COOH. Carboxylic acid react with sodium bicarbonate NaHCO3 to produce brisk effervescence of carbon dioxide. Brisk effervescence means rapid vigorous bubbling. This is a test which is used to detect these acids. Additionally, when carboxylic acid are treated with ethanol and concentrated sulfuric acid, they undergo esterification, which means forming ester, and esters have a fruity smell. This fruity smell confirms the presence of CaOH group, that is carboxylic acid group. Now let's see the test for alcoholic group, OH group. To test for the presence of alcoholic group, cetic ammonium nitrate CAN, is used, which turns red in the presence of alcohols. And to differentiate between primary, secondary, and tertiary alcohols, Lucas reagent, which is a mixture of anhydrous Cl2 and Gong HCl, this is employed. When a tertiary alcohol reacts with Lucas reagent, which is a solution of anhydrous zinc chloride in concentrated HCl, it immediately produces a turbid, which is a cloudy solution due to the formation of alkyl chloride. This happens because tertiary alcohols are more reactive than primary and secondary alcohols in this reaction. as the formation of stable carbocation intermediate is favored in tertiary alcohols, which allows the reaction to proceed rapidly. Therefore, with Lucas reagent, tertiary alcohols give turbidity immediately. And when a secondary alcohol is treated with Lucas reagent, it produces turbidity after about 5 minutes. While primary alcohols do not produce turbidity at room temperature, reaction with primary alcohols require heating to produce reaction with primary alcohols requires heating to proceed efficiently, while tertiary and secondary alcohols undergo the reaction more readily due to the stability of the carbocation formed, and it shows turbidity quickly at room temperature, while primary alcohols do not. So primary alcohols do not produce turbidity at room temperature. Now next we have the test for phenolic groups. First we have ferric chloride test. In this test, phenolic groups react with ferric chloride, that is FeCl3 solution, to form colored complexes, typically green, blue or violet, that confirm the presence of phenolic groups. This is due to the formation of FeO C6H5 whole 6 3 minus complex ion. Next test for phenolic group is Lieberman's nitroso test. In Lieberman's nitroso reaction, phenol produces a red color due to the formation of endophenol that changes to blue color when treated with sodium hydroxide NaOH due to the formation of endophenol ion. Nitrophenols do not give the ferric chloride test and Lieberman's nitroso test. So nitrophenols are an exception. They do not give the above two tests. Next we have aldehydes. Aldehydes contain CHO group. These aldehydes can be tested using specific reagents. Aldehydes produce a silver mirror with Tollens reagent and a violet color with Schiff's reagent. Both aliphatic and aromatic aldehydes respond to these two tests, Tollens test and Schiff's test. With failing solution, aldehydes gives a brick red precipitate of CO2O, and with Benedict's solution they form a red yellow precipitate. But these two tests are given only by aliphatic aldehydes. This Felling's test and Benedict's test is given only by aliphatic aldehydes, not by aromatic aldehyde. So this test help us to distinguish between aldehyde, aliphatic aldehyde from aromatic ones. Next we have the test for ketone group. This is the general representation of the ketone, where ketone is bonded to two alkyl groups and oxygen atom. Ketones react with sodium bisulfite through a reversible nucleophilic addition reaction to form a bisulfite adduct, which precipitates as white crystalline solid. This reaction is commonly used in qualitative analysis to detect ketones. Additionally, ketones produce a red or purple color when reacted with sodium nitroprusside, which is a test that helps in differentiating ketones from other carbonyl compounds like aldehydes. Now let's look at the test for the detection of primary amines, RNH2. When acetone and a few drops of sodium nitroprusside are added to aliphatic primary amines, a violet red color appears. This reaction occurs because aliphatic primary amines form a stable complex with sodium nitroprusside in the presence of acetone, which leads to the characteristic color change. Aliphatic primary amines react briskly, vigorously with nitrous acid. What is the formula of nitrous acid? It is HNO2. So, aliphatic primary amines react with HNO2 to release nitrogen gas, causing effervescence, while aromatic primary amines, when treated with nitrous acid and an alkaline solution of beta-naphthol, it forms red dye, which is called azo dye, through aerotrophilic substitution and coupling reactions, which are widely used in dyeing industries. Next we have secondary amines, which are the structure of RNHR. They give positive Lieberman's nitroso test. When these secondary amines are heated with nitrous acid, 1-2 drops of phenol and sulfuric acid, they produce blue color. Additionally, when secondary amines react with nitrous acid alone, they form N-nitrosamine, which appears as yellow, oily, dark colored liquid. So this is how we can detect presence of secondary amines group. So that's all about the theory part. Now we'll discuss some questions. So give me a moment. So let's start with the questions. So first we'll look at the question number 9. In a slightly acidic solution contain only Fe3 plus, Zn2 plus and Cu2 plus cations, that is ferric ions, Zn2 plus ions and copper 2 plus ions, which reagent when added in excess would allow for the identification and separation of Fe3 plus in a single step. So we have four options here: A 2 molar HCl, B 6 molar NH3, C 6 molar NaOH, or D H2S gas. If anybody know the correct answer, then drop the correct option in the comment box. We have identified the reagent which help us to identify and separate Fe3 plus ion in a single step. Let's move toward the solution. So the correct option is option B, 6 molar NH3. So when 6 molar NH3 is added in excess, Fe3 plus may form a precipitate or a colored complex which can be visually identified. The other ions, which are Zn2 plus and copper 2 plus, they remain in the solution, which allows for the separation of Fe3 plus in one step. So if the solution contains Fe3 plus, Zn2 plus and copper 2 plus ion, then on reacting with 6 molar NH3, the Fe3 plus form FeOH whole thrice brown precipitate, while the other ions, which are zinc ion and copper ion, they remain in solution as ZnNH3 whole 4 2 plus ion and CuNH3 whole 4 2 plus ions. This allows for the separation of Fe3 plus ion in single step. Therefore, the reagent 6 molar NH3 is able to identify and separate Fe3 plus from Zn2 plus and Cu2 plus in a slightly acidic solution due to its ability to form a distinct complex or precipitate with Fe3 plus, while the other ions remain in solution. Therefore, the correct answer is 6 molar NH3. Now let's move on to next question. The question here asks us to identify which of the given statement about the reactions of iron 2 and iron 3 plus ions with a specific reagent is correct. So here we have been given four options. Option A is Fe2 plus gives brown color with ammonium thiocyanate. Option B is Fe2 plus gives blue precipitate with potassium ferricyanide. Option 3 is Fe3 plus gives brown color with potassium ferricyanide. Or option D, Fe3 plus gives red color with potassium ferrocyanide. So you have to determine which statement accurately represents the expected result. The correct answer is option B. Fe2 plus gives blue precipitate with potassium ferricyanide. When Fe2 plus ion react with potassium ferricyanide, turns blue. That is, KFe FeCN whole 6 forms a blue precipitate. This happens because Fe2 plus combined with FeCN whole 6 3 minus ions to create this complex compound. So the blue precipitate of Fe2 plus ion with potassium ferricyanide is due to the formation of which compound? Turnbull's blue. KFe FeCN whole 6. The oxidation state of outer iron ion is +2 and the iron present inside the complex, its oxidation state is +3. Now here we have a reaction. This reaction shows the formation of Turnbull's blue when ferrous ions Fe2 plus react with potassium ferricyanide. Ferrous ions Fe2 plus react with ferricyanide FeCN whole 6 3 minus to form a complex which is Turnbull's blue KFe FeCN whole 6 which releases potassium ions. This reaction is a classic test for Fe2 plus. Now moving on. So let's look at the next question. A metal nitrate reacts with potassium iodide Ki to produce a black precipitate. And when excess Ki is added, this precipitate dissolves to form an orange colored solution. This question is asking us to identify the cation present in the original metal nitrate. Our options are A, He2 plus, B, Bi3 plus, C, Pb2 plus, or D, Cu plus. The correct answer of this question is option B, Bi3 plus, bismuth 3 plus ion. Bismuth nitrate, BiNO3 whole thrice, react with potassium iodide to form black BiI3 precipitate. Adding excess Ki dissolves this, which forms a soluble orange complex KBiI4. This shows Bi plus 3 forms complex with I minus. This reaction shows the formation of black precipitate of BiI3 when bismuth nitrate reacts with potassium iodide in aqueous solution. The equation indicates a double displacement reaction where Bi3 plus from the bismuth nitrate combined with I minus from the potassium iodide to form the insoluble compound BiI3, while K plus and NO3 minus remain in solution as spectator ions. Here we have another reaction. This reaction shows that the black precipitate of BiI3 dissolve in excess of Ki, that is potassium iodide, to form a complex ion, resulting in an orange color solution. This behavior is unique to bismuth 3 and confirms that the cation in the nitrate is Bi3 plus, bismuth 3 plus. So bismuth triiodide reacts with potassium iodide in solution to form potassium tetraiodo-bismuth 3, which has a orange color. This indicates complexation reaction where Ki provides iodide ions to form the complex ion KBiI4. Now let's move on to the next question. This question asks us to why sodium carbonate cannot be used instead of ammonium carbonate for the identification of calcium, barium and strontium ion in group 5 during mixture analysis. So we have to give the reason. Our options are A. Mg2 plus ions will be precipitated. Option B. Concentration of CO3 2 minus carbonate ions is very low. Option C. Sodium ions will react with acid radicals. Or option D. Na plus ions will interfere with the reduction of Ca2 plus, Ba2 plus and Sr2 plus ions. Let's move toward the solution. The correct answer is option A. Mg2 plus ions will be precipitated. So this is the reason why sodium carbonate cannot be used in place of ammonium carbonate. In the fifth group, ammonium carbonate is used with ammonium chloride. The ammonium chloride lowers the concentration of carbonate ions, CO3 2 minus ions, which prevents Mg2 plus from precipitating. So only group 5 radicals are precipitated. Using Na2CO3 would increase carbonate ions, causing Mg2 plus to precipitate also. Therefore, we do not use sodium carbonate in place of ammonium carbonate. Otherwise, it will cause precipitation of magnesium ions as well. Now, moving on to next question. This question asks us to match the given ion reagent combination with the corresponding color produced and then select the correct option from the provided options. After completing this question, we will have a better understanding of the characteristic color reactions of different metal ions when they react with specific reagent. The correct answer is option B, where A is matched with 4, B is matched with 3, C is connected to 1 and D is matched with 2. So here we have a table which contains the ion plus reagent and the color. When Fe3 plus react with potassium ferrocyanide, a blue precipitate forms. This is due to the formation of complex ferric ferrocyanide Fe4FeCN6 3. It is a complex compound responsible for the blue color observed when Fe3 plus react with potassium ferrocyanide. When Fe3 plus react with potassium thiocyanide, that is KSCN, a blood red complex FeSCN2 plus is formed. This reaction is used to detect Fe3 plus ions in solution. The color change indicates the presence of iron 3 ions. When Ni2 plus reacts with DMG dimethyl chloroxime, a cherry red complex NiDMG whole twice forms. This reaction is specific and used for detecting nickel ions. The color change indicates the presence of Ni2 plus in solution. Under strong acidic oxidation, MnO2 is oxidized to permanganate. MnO4 minus, which is dilute solution, appear pink. So Mn2 plus gives pink color. So MnO2 is oxidized to permanganate. MnO4 minus, which in dilute solution appears as pink color. Now moving on to next question. When a metal M is treated with NaOH, a white gelatinous precipitate X is obtained, and this dissolves in excess of NaOH. When compound X is heated strongly, it produces an oxide which is commonly used in chromatography as an adsorbent. Based on these observations, which metal is M? We are provided with 4 options. Option A is Zn, zinc, B is calcium, C is aluminium, and D is iron, Fe. The correct answer is option C, aluminium. When aluminium reacts with NaOH, it forms a white gelatinous precipitate of aluminium hydroxide, AlOH whole thrice. This precipitate dissolves in excess of NaOH sodium hydroxide to form sodium meta-aluminate. Here we have the reaction. So the reaction of aluminum ions with a limited amount of sodium hydroxide forming white gelatinous precipitate of aluminum hydroxide AlOH whole thrice is given, and when excess of NaOH is passed is added, the precipitate white gelatinous precipitate of aluminum hydroxide dissolves, which results in the formation of soluble sodium meta-aluminate. Let's continue our solution. So now aluminum hydroxide when heated strongly decomposes to form alumina Al2O3, which is an adsorbent used in chromatography. So here is the reaction which shows the thermal decomposition of aluminum hydroxide into aluminum oxide and water. When heated, aluminum hydroxide AlOH whole thrice breaks down into Al2O3 and 3H2O. It is a decomposition reaction where heat causes the breakdown of the aluminum hydroxide. Therefore, metal M is identified as aluminium Al. Calcium Ca is less reactive than sodium Na in the electrochemical series. Therefore, calcium cannot displace sodium from its aqueous solution. This is because sodium has a greater tendency to lose electrons and get oxidized compared to calcium. Zinc Zn, it reacts with sodium hydroxide to form sodium zincate. Sodium zincate is a soluble compound. So this reaction produces zincate ions and hydrogen gas. And iron Fe, it reacts with sodium hydroxide to form tetrahydroferrate to sodium, which is a soluble complex. So that's all for today's chemistry session. Thank you.
Hello everyone, good evening. So, in today's lecture, at first we summarize the chapter probability, some important concept from probability, and then we practice question of probability. Okay, so let's start. So, at first we will revise some important points of probability, and then we practice some question on probability. Okay, so first thing, what is equally likely event? So, equally likely event are the events if none of them is expected to occur in preference to the other. So for example, if we roll a die, then event if we take event as 1, occurring of 1, then what is the probability of 1? That is 1 by 6. What is the probability of coming 2, getting 2 is again 1 by 6. Probability of getting 3 is again 1 by 6. So all are equally likely event. Okay. And if you're talking about mutually exclusive and disjoint event, so if we have two event E1 and E2, then we say E1 and E2 are mutually exclusive event if they are disjoint. That means if we take the intersection of both event, we get phi. And exhaustive event, if we have a set of events E1, E2, dot 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 En, then they are called exhaustive event if the union of all this your whole sample space. Then we say events are exhaustive event. Okay, and set of events are mutually exclusive and also exhaustive event if ei intersection is phi for I not equal to j, and also the union of all eis is your sample space. Okay, next thing, some properties on probability. First thing is that probability is always greater than equal to 0 and less than equal to 1. Second thing, probability of sample space is your 1, and what is probability of phi? That is 0. Some important result that we directly can use in our question. So if the question related to n letters corresponding to n envelope, and we place the letter to envelopes at random, okay, then probability that letters are in right envelope is given by 1 by n factorial, and probability that at least one letter not in right envelope is given by 1 minus 1 by n factorial. Okay, next thing, addition theorem probability. One of the most important theorem on probability is that when we have to find the probability of union of two event, that is probability of A union B. Okay, probability of happening either A or B. So that is given by probability of A plus probability of B minus probability of A intersection B. In case if we have three sets, then three events, one set represent one event. Then in this case, probability of A union B union C is given by probability of A plus probability of B plus probability of C minus probability of A intersection B minus probability of B intersection C minus probability of C intersection A plus probability of A intersection B intersection C. Okay, we get this formula by principle of inclusion exclusion. Okay, next important theorem, that is your multiplication theorem. So multiplication theorem, that means if we have two event and we have to find the probability of occurring both, that is probability of when both event is occurring. So probability of A intersection B, and these are in the sequence, just like A is happening then B. Then how we get the intersection of A intersection B? So that is given by probability of A into probability of B given A. And if the event occur in the sequence B then A, then it is given by probability of B into probability of A when B is already occurred. Okay, that is the notation of conditional probability. Probability of A given B, it is a conditional probability. That is probability of A when B is already occurred. So there is a condition on happening of A. And one more thing, for this formula, we have to provide probability of A is not equal to 0 and probability of B is also not equal to 0. Next thing, independent event. So, if we have the set of event e1, e2, dot 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 en, then we say these events are independent event if probability of A intersection E2 intersection E3 intersection dot 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 intersection En is equal to probability of E1 into probability of E2 dot 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 probability of En. That means two events are independent if probability of their intersection is equal to probability of multiplication of individual probability. Okay. And one important, most important thing is that if your two event E and F are independent event, then the pair E and F complement, E complement and E complement and F complement are also independent. That means if probability of E intersection F is probability of E into probability of F, then probability of E intersection F other pairs for other pairs, probability like probability of E intersection probability of F complement is also probability of E into probability of F complement. Okay. Next theorem is your total probability theorem. So if we have an event A and n mutually exclusive exhaustive event like B1, B2 dot 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 Bn, then and we also have the values of probability of A given B1, probability of A given B2, probability of A when Bn is already occurred. So in this case, if we want to find the probability of A, then that is given by summation I is equal to 1 to n probability of Bi into probability of A given Bi. Okay. Next is Bayes theorem. So by using Bayes theorem, we can find the reverse case probability. That means if we have the probability of B and B given AI, then we can find probability of AI given B. Okay. So for Bayes theorem, let's suppose we have a sample space n and be the union of n empty disjoint subsets. Okay. So let S is equal to A1 union A2 union dot 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 an. So here AIs are mutually exclusive and exhaustive event. Okay. So for any event B, let's suppose we have another event B and B is A1 intersection B union A2 intersection B union dot 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 union AN intersection B. So if you want to find the probability of B, so that can be calculated by total probability law. That means probability of B is equal to probability of AI into probability of B given AI. When we take the summation of all this, we get your probability of B. And if you want to get the probability of AI given B, that means your second event is already occurred. Now you have to find the probability of AI. So that is calculated by Bayes theorem, and that is given by probability of AI intersection B by probability of B. That is probability of AI into probability of B given AI by summation of from I2 is equal to 1 to 8 probability of AI into probability of B given AI. Okay. And what is random variable? So random variable is a real valued function whose domain is sample space. Okay. So let's suppose we have a random variable x. We define random variable x that take the domain element from the domain. That is your sample space, and let it takes the value that is real valued x1, x2, xn dot dot xn, and probability with respect to this value, that is probability of x when x is equal to xi, is pi. Okay. So p1, p2, p3 dot dot pn are the respective probability. Then this is known as probability distribution of random variable x. Okay. And to define valid probability distribution for a random variable x with a real value that is x1, x2, xn, and with respective probability pi's, then it satisfies that is all pi's is greater than 0, and if you take the summation of all pi, we get 1. And mean of random variable is denoted by x bar and is given by p1 x1 plus p2 x2 plus dot 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 pi xi. Okay. And variance is defined by variance of random variable x is given by summation I is equal to 1 to n pi xi square minus summation I is equal to 1 to n pi xi whole square. Next thing is Bernoulli trials. So trials of a random experiment are called Bernoulli trials if they satisfy following condition. What are the condition? First thing, there should be finite number of trials. So I relate the Bernoulli trials with tossing a coin. So we toss a coin finite number of times. Okay. So it can be head and it can be tail. So second thing, trials should be independent. Okay. That is one trial is independent to another. Third thing is each trial has exactly two outcomes. Either it can be head, it can be tail. So we connect head with success and tail with failure. Okay. And also the probability of success and failure is remain the same in each trial as it is 1 by 2. So to understand Bernoulli trial, we relate this with tossing a coin. Okay. Next is Bernoulli distribution. So if we do an independent Bernoulli trials and we want to find the probability of our success, that means if we toss a coin n times, then what is the probability that you get r times head on your coin? So that is given by probability of x is equal to r, and that is equal to ncr p the power r q the power n minus r, where p is probability of success and q is probability of failure, and p plus q is equal to 1. Okay. And if we calculate the mean for this random variable x, that is n into p, variance is n into p into q. An important thing, mean is always greater than variance. Okay. So, so today's first question, in a leap year, the probability of having 53 Sunday or 53 Monday is. So, what is given here? First thing, it is a leap year. Okay. So, what is leap year? Number of days in leap year. That is important thing. That is 366. Second thing, the probability we are asked for to find a probability of having 53 Sunday, or each words in this question is important. First thing is leap year, so 366 days. Probability of having 53 Sunday or 53 Monday. Okay, so we have to find event is getting 53 Sunday or 53 Monday. So we have to find probability of let's suppose we have defined two event, that is event A is getting Sunday 53 Sunday and event B is getting Monday. So we have to find out the probability of having 53 Sunday or 53 Monday. That means A union B. Okay, so or means union. If there is and, then we have to find probability of A intersection B. So it is also important to read the question and understand what is asked for. Okay, so then which option is correct? It is 2 by 7, B 3 by 7, C 4 by 7, D 5 by 7. So try this question. What is formula for finding probability? If sample space has total n element and event A has total m element, then probability of event A is given by m by n. Okay, so we just need to apply this formula. So at first we have to find all possible cases, all possible outcomes to find the value of n, and then we also need to calculate the all possible favorable outcomes. Okay, then you can directly apply the formula of probability to find which option is correct. Okay, so try this question, everyone, try. First think as what is the number of week in a leap year or in any year. Okay, Okay, tell number of days in a week. Anyone? Very common thing. Number of days in a week. Okay. Correct answer is option B. That is 3 by 7. So how we get this? So first thing, a normal year has how many days? 365. So which is 52 weeks and 1 day. Just divide by 7. So we get total 52 week on a year plus 1 day. And this 1 day can be any day. It can be Sunday, Monday, Tuesday. It can be any day. Okay. Second thing, but in the question is given a leap year, and leap year has 366 days. So total 52 week and extra 2 days. And this 2 days can be any pair Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday. Okay. So let's solve. Since leap year has 366 days, that means 52 week plus 2 days. So that extra 2 days can be what? It can be Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, Friday, Saturday, Saturday, Sunday. Only this case is possible. Okay. So we have to find probability of 53 Sunday or 53 Monday. So total possible case is 7. And we have to find either Sunday, 53 Sunday. So 52 weeks, so 52 Sundays already that we have. So if the other two extra days, if one of the is Sunday, then we get 53 Sunday. And if we one of the Monday, then we get 53 Monday. So as it is or, so possible cases for this event is it can be Sunday, Monday, then both 53 Sunday and 53 Monday. If it can be Monday, Tuesday, then 52 Sunday or 53 Monday. And last, it can be Saturday, Sunday. So now 53 Sunday and 52 Monday. So total three cases that satisfy this condition. That is, in a leap year, there is 53 Sunday or 53 Monday. So total 7 and for this event satisfy 3. So what is the probability? 3 by 7. Clear? Very simple question. Okay, let's go to the next question. A number is chosen at random. Okay, so among the first 120 natural number. So let's suppose we have a bag with 120 natural number. First 120 natural number, that is 1, 2, 3 till 120. And we choose a number from the bag at random. Okay, then the probability of the number chosen being a multiple of 5 or 15 is. So what is the event? Event is with choosing a number and that number is being multiple of 5 or 15. Okay, so we have to find the probability of this event. That is either you get a multiple of 5 or multiple of 15. Okay, so try this question. Option A is 1 by 8, option B is 1 by 5, option C 1 by 24, option D 1 by 6. So apply the similar approach as in question number 1, because there is also or 5 or 15. Okay, so try this question. Okay, let's solve. So correct answer is B, that is 1 by 5. Okay. So first formula that we use that is important for this question is number of element in A union B is given by number of element in A plus number of element in B minus number of element in A intersection B, and probability of event A is given by number of element in A by number of element in sample space. So in total we have 120 natural number, first 120 natural number, and to find the number of element in event, so number of multiples of 5, total number of multiples of 5 till 120. So that is given by number of A, and that is 24. How we get this? Just divide 120 by 5, as 120 is multiple of 5. So we get 24 multiples, and total number of multiples of 15, that is 120 by 15, that is 8. Okay. And n A intersection B, that is a number that is multiple of 5 as well as 15. So if any number is multiple of 15, then it is also multiple of 5. So we get number of A intersection B is same as number of element B, that is 8. So to find number of element in A union B, that is either it's multiple of 5 or 15. So that is your 24 plus 8 minus 8, that is 24. Clear? So now we have number of element in A union B and total element. So required probability is 24 by 120, and that is 1 by 5. Clear? So next question. Consider two event A and B. If odds against A are 2 is to 1 and those in favor of A union B are as 3 is to 1, then so what is given? We have two event A and B, and it is given that odd against A are 2 is to 1. So what is the formula to find probability of odds against A and probability to find the favor of A union B, that is given 3 is to 1. Okay. Then which option is correct? So option A is probability of B is greater than equal to 1 by 2 and less than equal to 3 by 4. Option B, probability of B is greater than equal to 5 by 12 and less than equal to 3 by 4. Option C, that is probability of B is greater than equal to 1 by 4 and less than equal to 3 by 5. Or option D, that is none of this. Okay, so try this question. We just need to apply the formula of odds against A and favor of event. Okay, so try this question. Are you guys solving or not? Anyone? Which option is correct? Okay, let's solve. So correct answer is option B. That is probability of B is lying between 5 by 12 and 3 by 4. So first formula that we use, it's probability of odds in favor of A is probability of A by probability of A complement, and probability of odds in against A is probability of A complement by probability of A. And probability of A complement is given by 1 minus probability of A, and probability of A union B is given by probability of A plus probability of B minus probability of A intersection B. And most important thing, if B is a subset of A, then probability of B is less than probability of its superset, that is A. Okay. So it is given that probability of odds in against A, that is 2 is to 1, that is probability of A complement by probability of A is 2, and probability of odds in favor of A union B is given by 3 is to 1, that is probability of A union B by probability of A union B complement, that is 3. So we have probability of A, that is 1 by 3, and the probability of A union B is 3 by 4. How we get this? So we just use this formula. That is, if A is equal to probability of A complement by probability of A, that is 2, probability of odds in against A. So we use the formula of probability of A complement, that is 1 minus probability of A. If we simplify this, that is 1 minus probability of A by probability of A is equal to, we get probability of A, that is 1 by 3. And if we write the second one with probability of A union B by probability of A union B complement as 1 minus probability of A union B, then from here we get the value of probability of A union B, that is 3 by 4. Okay. Now second thing, what is the probability of A union B? So this is calculated by probability of A plus probability of B minus probability of A intersection B. And as the probability of A intersection B is a positive number, so it is less than equal to probability of A plus probability of B. So from here we get that probability of A union B is 3 by 4. So 3 by 4 less than equal to 1 by 3 plus probability of B, as probability of A is 1 by 3. So from here we get, if you solve this, probability of B is greater than equal to 5 by 12, and as B is subset of A union B, so probability of B is less than probability of A union B, that is 3 by 4. So from here we get probability of B is lying between 5 by 12 and 3 by 4. Okay. So next question. A and B are events such that probability of A is 0.4 and probability of B is 0.3 and probability of A union B is 0.5. Then what is the probability of B given A? Okay, option are 2 by 3, 1 by 2, 3 by 10, 1 by 5. So try this question. Just need to apply the formula. We have to find probability of event B given a conditional probability. So what is the formula for conditional probability? Recall the formula and solve. Okay, Varsha, option B. Okay, let's solve. Very good. Correct answer is option B, that is 1 by 2. So how we get this? So first formula that we use is that conditional probability. That is probability of A when B is already occurred. So that is given by probability of A intersection B by probability of B. Okay. And what is probability of A union B? So that is given by probability of A plus probability of B minus probability of A intersection B. So what is given? Probability of A is 0.4, probability of B is 0.3, and probability of A union B is 0.5. And we have to find probability of B given A. So from the formula of conditional probability, probability of B given A is, as A event is already occurred, so that event is in the denominator, and for numerator, the intersection of both event. So probability of A intersection B by probability of A. So now as the probability of A union B is probability of A plus probability of B minus probability of A intersection B. So probability of A intersection B is probability of A plus probability of B minus probability of A union B by probability of A. So substitute all the value. So we get 0.4 plus 0.3 minus 0.5 by 0.4, that is 1 by 2. Clear? Next question. If A and B are two events such that probability of A is 1 by 2, probability of B is 1 by 3, and the probability of A given B is 1 by 4, then what is the probability of A complement intersection B complement? Options: 1 by 12, option B 3 by 4, option C 1 by 4, option D 3 by 16. So try this question. We have to use the given information to find this probability. Okay, so at first recall what is the formula to find probability of A complement intersection B complement. Can we write this formula by using the terms probability of A, probability of B, and probability of A given B? Okay, so try this question. Okay, let's solve. So correct answer is C, that is 1 by 4. So probability of A complement intersection B complement is, we apply the De Moivre's theorem. So we get 1 minus probability of A union B. And what is the formula for probability of A given B? So that is probability of A intersection B by probability of B. So in the question it is given that probability of A is 1 by 2, probability of B is 1 by 3, and probability of A given B is 1 by 4. So what is probability of A complement intersection B complement? And that is equal to 1 minus probability of A union B. And formula for probability of A union B is 1 minus probability of A minus probability of B plus probability of A intersection B. Okay. So probability of A intersection B. So if you apply the formula of probability of A given B, so from there we get probability of A intersection B is probability of B into probability of A given B. So now we have all this value. So put the values. So we get 1 minus 1 by 2 minus 1 by 3 plus 1 by 4 into 1 by 3. That is 1 minus 1 by 2 minus 1 by 3 plus 1 by 12. That is, if we simplify this, we get 1 by 4. So correct answer is 1 by 4. Okay. Next question. It is given that event A and B are such that now we also have probability of A is 1 by 4, probability of A given B is 1 by 2, and probability of B given A is 2 by 3. Then what is the probability of event B? Okay, options are 1 by 2, 1 by 6, 1 by 3, and 2 by 3. So try this question. Varsha, which option is correct? So correct answer is that is C, 1 by 3. So first of all, let's see what main points and formula we are going to use. So we should know this conditional probability formula, that is probability of A given B is probability of A intersection B by probability of B. So given that probability of A is 1 by 4, probability of A given B is 1 by 2, and probability of B given A is 2 by 3. And we know that probability of A given B is probability of A intersection B by probability of B. And probability of B given A is probability of B intersection A by probability of A. We have to find probability of B. Okay, so we just use the above two formula to find probability of B. Okay, so probability of B is equal to probability of B given A into probability of A by probability of A given B. Okay, so now substitute the values, put the values, we get 2 by 3 into 1 by 4 by 1 by 2, that is 1 by 3. Clear? Any doubt till here? Okay, so just wait for a minute. Okay, so next question. First, let's understand the question, then we solve. So here we have two event A and B. Okay, now in the question we are given that probability of A occurring, that is probability of A is 0.c and probability of B is 0.2, and also conditional probability is given, meaning that probability of A given B, that is B is already occurred, then what is the probability of A, that is 0.5. Then what is the probability of A complement given B complement? Okay, so we need to find the conditional probability, that is probability of A complement given probability of B complement. Now options are given. So first option, that is option A, 1 by 10, option B, that is 3 by 10, option C, that is 3 by 8, and option D, 6 by 7. So which option is correct? Try this question. So which option is correct? Correct answer is option C, that is 3 by 8. So formula that we use. So first thing, probability of A given B is probability of A intersection B by probability of B. Then you should know that the probability of A complement intersection B complement means 1 minus probability of A union B, and probability of A complement is equal to 1 minus probability of A. So if you know this point, then let's solve. So given that probability of A is 0.6, probability of B is 0.2, and probability of A given B is 0.5. So probability of A intersection B is, just apply the formula of conditional probability. So we get probability of A intersection B is probability of A given B into probability of B. So now put the value of probability of A given B and probability of B. So we get 0.5 into 0.2, that is 0.1. So probability of A complement given B complement. So just apply the formula of conditional probability. So from here we get probability of A complement intersection B complement, that is probability of B complement, and we can write the numerator part as probability of A union B whole complement, that the divided by probability of B complement, and from here we get 1 minus probability of A union B by 1 minus probability of B. So we can write probability of A union B as probability of A plus probability of B minus probability of A intersection B. So we get 1 minus probability of A minus probability of B plus probability of A intersection B by 1 minus probability of B, that is 0.2. 1 minus 0.2. So when we substitute those values, we get 3 by 8. Clear? Next question. If two events A and B are such that probability of A complement is 0.3, probability of B is 0.4, and probability of A intersection B complement is 0.5, then what is the probability of B given A union B complement? Options are option A 1 by 4, option B 1 by 5, option C 3 by 5, option D 2 by 5. Okay, so try this question. First, see what is given. It is given that probability of A complement is 0.3 and the probability of B is 0.4 and the probability of A intersection B complement is 0.5, and we need to find the conditional probability of event B given A union B complement. Okay, so apply the formula of conditional probability to find which option is correct. Okay, option B, 1 by 5. So let's check. Correct answer is option A, that is 1 by 4. Okay, so let's see how we get this. So formula that we use, first thing, probability of A given B is probability of A intersection B by probability of B. And probability of A union B is probability of A plus probability of B minus probability of A intersection B. And to find probability of A, so probability of A is given by probability of A intersection B plus probability of A intersection B complement. Okay. And one other important formula, that is to find the probability of A complement, that is given by 1 minus probability of event A. So in the question we are asked for what is the probability, what is the conditional probability of probability of event B given A union B complement. Okay, so by the definition of conditional probability, this is equal to probability of B intersection A union B complement by probability of A union B complement. So from here we get probability of A intersection B, because when we open B intersection A union B complement, we get B intersection A union B intersection B complement, and B intersection B complement is phi. So we get probability of A intersection B by probability of A plus probability of B complement minus probability of A union intersection B complement. Okay, so from above we apply the formula. So we get probability of A intersection B is equal to probability of A minus probability of A intersection B complement. We apply the third formula by put the values. So we get 0.7 plus 0.6 minus 0.5, and from here we get 0.7 minus 0.5 divided by 0.8, and when we solve this you get 1 by 4. So probability of B given A union B complement is 1 by 4. Clear? Next question. So here we are given two events C and D, and C is subset of D. Okay, so we have two events C and D, and event such that C is subset of D. Okay, and probability of D is not 0. So we need to find out which of the statement given below is true and correct. Okay, so which option is correct among the following? Option A, that is probability of C given D is greater than or equal to probability of C. Option B, probability of C given D is less than probability of C. Option C, probability of C given D is equal to probability of D by probability of C. And option D, that is probability of C given D is probability of C by 1. So we have to choose which option is correct. It means which option is true for the following condition if C and D are even in such that C is subset of D and probability of D is not equal to 0. Okay, so try this question, theory based question. Anyone? Which option is correct? Unit. Okay, option A. Let's check. Very good. Correct answer is option A. That is probability of C given D is greater than equal to probability of C. So, first of all, first formula, that is conditional probability formula. So, how to find probability of event A given B is equal to probability of A intersection B by probability of B. Another formula, if C is subset of D, then probability of C intersection D is probability of C, because C intersection D is again C, because C is subset of D. Simple set theory. Okay, so let's solve probability of C given D. So apply the conditional probability, that is probability of C intersection D by probability of D, and as C is subset of D, so is equal to probability of C by probability of D. So consider it as equation number 1. Okay, now also, as we know by the property of probability, as probability of D is not equal to 0 and probability of D is always lies between 0 and 1, so probability of D is less than equal to 1. Okay, so if probability of D is less than equal to 1, so it's reciprocal, that is 1 by probability of D is greater than equal to 1. So from here you get probability of C by probability of D is greater than equal to probability of C. That is your equation 2. So when we use equation 1 and equation 2, so first equation is probability of C given D is equal to probability of C by probability of D, and second thing, probability of C by probability of D is greater than equal to probability of C. So when we use the both equation, so we get probability of C by D is greater than equal to probability of C. So correct option is option A. Good. So next question. So in this question we have two event E and event F. And important thing, both are independent event such that probability of E is greater than probability of F. Now we have to find the probability of both. So what it is also given that probability that both E and F happen is 1 by 12, and the probability of that neither E nor F happen is 1 by 2. Then which option is correct? First, probability of E is 1 by 3, probability of F is 1 by 4. Option B, probability of E is 1 by 2 and probability of F is 1 by 6. Option C, probability of E is 1 and probability of F is 1 by 12. And option D, probability of E is 1 by 3 and probability of F is 1 by 2. Okay, so try this question. If you consider E and F as event, then how you write this statement, that is probability of both E and F is happen is 1 by 12? By using the operation on the set, that means that by using union and intersection. If we say the probability that both E and F happen is 1 by 12. Okay, you think option A? Anyone? One thing is clear, that probability of E is greater than probability of F because it is given. Okay. Okay, let's solve. So your guess is correct. Correct answer is option A, that is probability of E is 1 by 3 and probability of F is 1 by 4. Let's see how we get this. So it is given that if two events are independent, then what is the probability of A intersection B? If A and B are independent, then probability of A intersection B is product of probability of A and probability of B. That is probability of A into probability of B. And if we have the probability of A, then we can calculate the probability of A complement. And if we have the probability of A complement, then we can calculate probability of A. because probability of A is given by 1 minus probability of A complement. So let's solve. So first thing, it is given that E and F are independent. So probability of E intersection F will be equal to probability of E into probability of F, and that is given 1 by 12. That is probability that both E and F happen. Both. It is not or. Okay. That means intersection. E is occurring, also F is occurring. That means E intersection F. And that is given 1 by 12. But as this both event is independent, so intersection is given by its product. So probability of E into probability of F, that is 1 by 12. So remember this as equation number 1. So now we have first condition on probability of E and probability of F, that is its product should be 1 by 12. Okay. So option D is already discarded because we must have probability of E into probability of F is 1 by 12. So if you check the option A, that is 1 by 3 into 1 by 4, that is 1 by 12. Okay. So let's find another condition. So we get exact answer. Second thing is that it is given that probability that neither E nor F happen is 1 by 2. Neither E means E complement nor F complement, and both are happening. So neither E nor F is happening. So probability of E complement intersection F complement is given, and that is 1 by 2. And we also know that if A and F are independent, then other pair like E and F complement, E complement and E complement and F complement, all these pair are also independent. So probability of E complement intersection F complement, as this both event is independent, so we get probability of E complement into probability of F complement, and that is 1 by 2. Okay. Now we need a condition on probability of E and probability of F. So now we use the formula of probability on complement. So we can write probability of E complement as 1 minus probability of E into 1 minus probability of F, that is equal to 1 by 2. So from here we get multiply, we get 1 minus probability of E minus probability of F plus probability of E into probability of F, that is 1 by 2. So this is your equation 2. So we have equation 1. What is probability of E intersection F is probability of E into probability of F, that is 1 by 12. And equation 2, that is 1 minus probability of minus probability of 1 minus probability of F minus probability of E plus probability of E into probability of F, that is 1 by 2. So from equation 1 and 2 we get 1 minus probability of F minus probability of E plus 1 by 12 is equal to 1 by 2. And when we solve this, we get probability of F plus probability of E is equal to 7 by 12. So one more condition, that is probability of E plus probability of F. When we add this both probability, we get 7 by 12. Okay. So to choose which option is correct, the option must satisfy all the condition that we get. The condition, that is probability of E into probability of F is equal to 1 by 12. Second condition, that is probability of F plus probability of E is equal to 7 by 12. And one more condition that is given in question, that is probability of E is greater than probability of F. So if we use all this condition, the option must satisfy this all three condition. So if we see which option is true, we have that option must satisfy all the condition, and that is first option, that is probability of E is 1 by 3 and probability of F is 1 by 4. Okay, clear? Just discard the all option by the conditions. The option must satisfy all these three conditions. Okay, and which satisfy all these three conditions, that is your answer. So therefore the option number A will be the correct option. Clear? Next question. Interesting question. An unbiased coin is tossed if the result is a head. So at first, carefully read the question and note each information that is given in the question. So at first, we have an unbiased coin. That means unbiased mean probability of getting head and probability of getting tail is same. That is 1 by 2. Next, If the result is head, not now suppose when you toss a coin we get head. Okay, then a pair of unbiased dice is rolled. So when you get head, the a pair of unbiased dice, two dice are is rolled. Okay, and the sum of the number obtained is noted. So first thing, we toss a coin, and if you get head, then you roll two dice. Okay, and the sum of number obtained is noted. Let's suppose we get on a first die we get 2, on a second die we get 3. So sum is 2 plus 3, that is 5. So 5 is noted. Okay, now if you get tail, that means if the result is tail when you toss a coin, then a card from a well shuffled pack of 11 cards. So now we have pack of 11 cards with number 2, 3, 4 till 12. And from this 11 card we pick a card. That is your second experiment. Okay? When you get a tail, then you do this. A card from well shuffled pack of 11 card. And the number on the card is noted. So which card you get? Let's suppose we pick card number 4. Then we note number 4. Clear? The probability that the noted number is either 7 or 8 is. Then we are asked for the probability of the event, that is the noted number is either 7 or 8. So which option is correct? Option A 192 by 401. Option B 193 by 401. Option C 193 by 792, and option D 17 by 75. So very interesting question. So try this question. To solve question related to probability, we have to focus on each minute detail. Okay. So in this question, there are two cases. Okay, Jeet. As probability is also very important chapter, but as you are weak in this chapter, so you can focus on other chapter. Because main thing is to get good marks so that you get good college. Okay. Okay, option C. Let's check. Very good. Correct answer is option C, that is 193 by 792. Let's solve. So, first formula is if A and B are two events, then probability of A and B is given by, if probability A and B are independent event, then probability of A and B is probability of A into probability of B. And probability of A or B, it means probability of A union B. If they are disjoint event, then it is given by probability of A plus probability of B. Okay. So in this question, we are asked for find the probability that noted number is 7 or 8. Okay, but there is two cases. If your result is head, then a pair of unbiased dice is rolled. Okay, then what is the number of possible outcomes? It can be 36, 6 into 6, 36. It can be 1 comma 1, it can be 1 comma 2, 1 comma 3, 1 comma 4 till 1 comma 6, then 2 comma 1, 2 comma 2. In such way, ordered pair AB, where A is lies from 1 to 6 and B is lies from 1 to 6. Okay, then we are noted the sum of the number get in the dice. Okay, so getting the sum at 7 or 8 from two dice. What are the possible cases to getting 7? It can be 1 comma 6, it can be 2 comma 5, it can be 3 comma 4, it can be 4 comma 3, it can be 5 comma 2, and it can be 6 comma 1. Total 6 cases. So probability of getting number sum as 7 is 6 by 36. Because total possible is 36. 6 into 36, 36. That is total number of pair. Okay, ordered pair. Okay, now probability of getting 8. So what are the possible numbers which sum is 8 on the dice? It can be 2 comma 6, it can be 3 comma 5, it can be 4 comma 4, it can be 5 comma 3, it can be 6 comma 2. Okay, so total 5. So we get probability of getting the sum as 8 is 5 by 36. As this both event is disjoint, so probability of event A or B, that means probability of getting sum as 7 or 8, so that is 6 by 36 plus 5 by 36, that is your 11 by 36. Okay, now second case is also possible, that is probability of getting the card with number 7 or 8. When you get tell, then what you do, then we pick up card from a well sold pack of 11 cards with number 2 3 4 dot 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 12. So from this card, when you take 7 or 8, so total 2 possible, 7 or 8, and total number of cards is 11. So what is the probability? That is 2 by 11. Clear? So required probability. We have to find the probability that noted number is either 7 or 8. So total there are two possible case. So we add the probability of both cases. So first case, that is we toss a coin and we get head. So probability of getting head is 1 by 2 into, then both are even are independent, and probability of A and B is probability of A into probability of B. So probability of B, so that is we get a sum 7 or 8, that is 6 by 36 plus 5 by 36, 11 by 36. So we get 1 by 2 into 11 by 36. And for second case, when we pick a card from shuffled pack of 11 cards, we get 1 by 2 into 2 by 11. That is 11 by 72 plus 2 by 22. That is so correct. So answer is 193 by 792. Clear? So next question. A bag contains 3 red and 3 white balls. Two balls are drawn one by one. The probability that they are of different color is option A 3 by 10, option B 2 by 5, option C 3 by 5, and option D none of this. Okay, so take this question as homework, take the screenshot and try this question. Okay, so that's all for today. Okay, thank you.
Hello students, in today's lecture we are going to learn about semiconductor electronics and logic gates, and this is part 2. Alright, this is our disclaimer. So in today's lecture we will discuss first logic gates and truth table. After that we will discuss OR gate, then we will discuss uh, AND gate, then we will discuss the NOT gate, then we will discuss combination of logic gates. All right, so these are the topics which we will cover in today's lecture. All right, everyone. So our first concept is a logic gates and truth table. All right. So now we will discuss logic gates and truth table. All right. So basically, here a question arises: what is a logic gates? Think about it. So we can say a logic gate is an electronic digital circuit that performs a specific logical operation on one or more binary inputs to produce a single binary output. Okay, so what is inputs and what is outputs? Yes or no? There is a question arises. So logic gates have two or more inputs but always produce only one output. Okay, inputs and outputs are represented using binary digits 0 and 1. Okay, 0 means high and 0 means low and 1 means high. Okay, and if we talk about the types of basic logic gates, so we can say there are three. Listen carefully, there are three uh, primary types of logic gates that form the foundation of digital electronics. First, OR gate, second, AND gate, and third, NOT gate. Okay, so if we talk about the OR gate, this is the symbol of OR gate. Okay, so we can say output 1 if any inputs is 1. Okay, and if we talk about the AND gate, so we can say output 1 only if all inputs are 1. And if we talk about the NOT gate, so we can say a single input gate that outputs the complement or negation of input. Okay, so here we will see now Boolean expressions. All right, so each gate corresponds to a Boolean expression. For OR gate, it will be what? It will be y equal to a plus b. Okay. For AND gate, y equal to a dot b. And for NOT gate, y equal to a bar. All right. Yes or no? Anyone? Clear? Clear? Yes or no? All right. So these are the three logic gates: OR gate, AND gate, and NOT gate. Okay. Now next concept is truth table. So what is a truth table? A truth table is a tabular representation that shows all possible combinations of inputs and the corresponding output of a logic gate or circuit. Alright, basically, truth table helps us to analyze and predict the behavior of the logic gate for every possible input. Clear? And inputs are represented by binary digits. Okay, 0 and 1. 0 means false and 1 means true. All right, now we will understand each gate one by one in detail. So listen carefully, everyone. All right, so first we have OR gate. Okay, an OR gate is a fundamental digital logic device. It has two or more inputs and produce one output. Okay, two inputs or more than two inputs and produce a one output. Okay, so the purpose of the OR gate is to combine multiple input signals and give a single output. Okay, so we can say uh, according to a logical OR operation here, the OR gate symbol looks like a curved shape. Look at here, the curved shape. All right. All right. So we know the OR gate symbol looks like a curved shape pointed to the right. Okay, here it has inputs on left side. Okay, and one output on the right side. All right. The output y of an OR gate is represented by the Boolean expression y equal to So y equal to a plus b. All right, this one. Now here the y indicates y equals a or b. All right. So look at here. This is the truth table for OR gate. Y equal to a plus b. All right. So this is our truth table that shows all possible input combinations and the corresponding output. Okay. So for two inputs A and B, okay, the truth table is this one. All right. For two inputs means what? It means there is a four combinations 0 0, okay, 0 1 1 0 or 1 1, okay, and one we know this is what, this is OR gate, so we can say when both inputs are 0 the output is 0, okay, the when a 0 b 0, it means when both inputs are 0 the output is 0, and both or we can say when either a or b is 1, okay, a or either a or b is 1, okay, or both are 1, both are 1, the output is 1, the output is 1. Look at here this one, okay, so this is the all about the uh, OR gate, okay. So here the output of the OR gate is high if any one of the more inputs are high, okay, and the output is low uh, only when all inputs are low, okay. So this makes the OR gate useful in circuits when you want to activate an output if any one of the several conditions are true. All right. Now we will discuss AND gate. Okay, an AND gate is a basic digital logic device similar to the OR gate. Okay, it has two or more inputs and produces one output. All right. So the AND gate combines the input by performing a logical AND operation, meaning the output depends on whether all inputs are true. Okay, so the AND gate symbol looks like uh, a flat ANDed semicircle. Look at here with inputs on the left and output on the right. Okay, so the output y of an AND gate is represented by Boolean expression y equal to a dot b. Okay, and this indicates y equals to a and b. Okay, so here a dot represents the logical AND operation. This means y is true only when both a and b are true. All right. So uh, the expression here y equal to a dot b means what? Output y equal to 1 if we can say if both inputs a equal to 1 and b equal to 1, and output y equal to 0 if any input is 0. So this makes the AND gate is a gate that requires all conditions to meet the produce a high output. All right. So the truth table lists all possible input combination and their outputs for the AND gate. All right, so there is a two inputs means what? Two inputs means there is a four combinations: 0 0 0 1 1 0 or 1 1. Okay, and we know the condition for both inputs should be 1, so output will be high. All right, this one last one, yes or no? So the output of the AND gate is high only when all inputs are high. So the output is low if any input is low. Okay, this property makes the AND gate useful in circuits where you want output only when multiple conditions are simultaneously true. All right, everyone. And for all other inputs combinations, the output is 0. Okay. Next, we can say the next gate is NOT gate. All right. So a question again here arises: what is NOT gate? Think about it. So a NOT gate is a fundamental digital logic device that differs from and OR gates because it has only one input and one output. All right. So its main function is to invert or complement the output signal. This means if the input is 1 or we say true, the output will be 0 or false. And if the input is 0, the output will be true. Okay. So the symbol for NOT gate is a triangle pointing, all right, to the right side with a small circle. This one, all right. And at the output, so the input is on the left side. This one, all right, and the output is on the right side here. So the small circle represents the inversion or negation operation. The Boolean expression for the NOT gate is written as y equal to a bar. Here y is the output and a is the input. So which indicates we can say a bar over a called a complement or not. All right, means y is the logical negation of a. So the expression y equal to a bars means if a equal to 0 then y equal to 1. If a equal to 1 then y equal to 0. Simply put the NOT gate flips or inverts the input value. All right. So this is the truth table, shows how the NOT gate behaves for all possible inputs. This table confirms that the output is always the opposite of the input. Alright, so for input A and outputs Y. So for 0, output will be 1. For 1, output will be 0. Alright. So the NOT gate inverts its single input. Symbolically, it is represented as y equal to a bar. So the output is 1 if input is 0, and output is 0 if input is 1. Alright. So the NOT gate is essential in digital electronics because it allows us to invert signals. Students, it is commonly used in combination with other gates and or to create more complex circuit. Alright. For example, it helps implement logic functions where certain conditions need to be negated or turned off. So together, the basic gates and or and not can be combined to build virtually and digital system to form simply switches to complex processors. All right. Now we will discuss a combination of logic gates. NAND gate and NOR gates are used to make any gate. Clear? So first we will discuss about the NAND gate. Alright everyone. So basically the NAND gate is a fundamental digital logic gate that combines the functions of an AND gate and followed by a NOT gate. Okay. Essentially it performs the AND operation on its inputs and then inverts the result. Okay, so because of this, NAND gate is often called a universal gate since any other logic gate can be constructed or using only NAND gates. Alright, so we can see the output of the NAND gate is the complement of the AND gate input. Okay, right? First, the AND gate check if both inputs are 1. Alright, and then the NOT gates inverts the AND gate. Clear? So, if both inputs are 1 and the AND gets output 1, but NAND gate outputs 0. Okay, so this is the symbol. This is AND gate. This is NOT gate. So when we combine both, you will be get the NAND gate. Okay, for all other inputs combinations, the NAND gate outputs 1. So the NAND gate symbol looks like an AND gate symbol, a D-shaped figure. Look at here, this one. Okay, with a small circle. This one, small circle. This one at this output. This small circle indicates the negation of or not operation applied to the NAND gate output. And the Boolean expression for NAND gate with inputs A and B is y equal to A dot B whole bar. Alright, here A dot B represents the AND operation and overline indicates the note of complement. This means the output y is true except when both a and b are true. Okay, so the expression y equal to a dot b whole bar can read as the output y is the negation of a and b. So if a is equal to 1 and b equal to 1, then a dot b equal to 1. Okay, and output y equal to 0. If either a or b or both are 0, then a dot b equal to 0 and the output y equal to 1 in case of NAND gate. And this is the truth table for NAND gate. So the truth table lists all possible input combination of A and B and the corresponding output Y. Alright, clear? So look at here. Uh, the output Y is 1 for all cases except when both A and B are 1. Okay, both because the NAND gate can be used to create any other gate and or not nor XOR, it is called a universal gate. Alright, this makes it very important in digital circuits or we can say digital electronics, uh, okay, to design circuits. It simplifies hardware design since only one type of gate can be used to build complex logic circuits. Students, note NAND gates are commonly used in memory devices, microprocessors, and various digital systems. All right, and NAND gates out the NAND gate output is the negation of AND gate. All right. So this is the truth table. All right. So this input two inputs, a number of combinations for 1 0 0 1 or 1 1. Okay, and the y prime shows uh, AND operation and y shows NAND operation. Okay, so 0 0 in AND operation it will be 0 1 0 0 0 0 1 0 and 1 1 1, and the complement of y prime it will be 0 1 and complement of 0 1 and complement of 0 1 and complement of 1 0. All right. Now the second is NOR gate. All right. So the NOR gate is a fundamental logic gate that combines the functions of an OR gate followed by a NOT gate. Okay, it performs the OR operation on its inputs. Okay, and then inverts the result. Like the NAND gate, the NOR gate is also universal gate, meaning that any other logic gate can be constructed using only NOR gates. So the NOR gate first checks if either or both inputs are 1. All right. So the operation or operation. All right. If either input A or B is 1, the OR gate is output is 1. All right. All right. So look at here. This is the symbol of NOR gate. All right. So like a NAND gate, the NOR gate is also universal gate, meaning that any other logic gate can be constructed using any other NOR gate. Okay. So the logic symbol of NOR gate is look at here, y equal to a plus b complement. All right. And the Boolean expression is this one, y equal to a plus b complement. All right. And this is the truth table. For two inputs, the combination is 0 0 1 0 0 1 or 1 1. All right. So this is the combination, and this is the output of OR gate, and this is the output of NOR gate. All right. For 0 0 0 for 1 0 1 and 0 1 1 and 1 1 1. Okay, and their complement for 0 1 for 1 1 0 and 1 0 for complement of 1 0. Okay, and note NAND and NOR gates also called a universal logic gate. So the Boolean expression obey the commutative law, associative law as well as distributive law. So let's see. So commutative law is A plus B equal to B plus A and A dot B equal to B dot A. Associative law A plus B plus C equal to A plus B plus C and A dot B dot C equal to A dot B dot C. Okay, both OR plus and operations are associative. This means if you are adding or multiplying three variables, you can group them in any way. And distributive law A dot B plus C equal to A dot B plus A dot C. Okay, A plus A dot B equal to A and A dot A complement plus B equal to A dot B and A dot B complement equal to A complement plus B complement and A plus B complement equal to A complement dot B complement. Okay, so this is the De Morgan's theorem. This 7th, 8th and 9th. Okay, so this is the some uh, laws in combination of logic gates. So let's see summary. We discussed in today's lecture logic gates and truth table, then the OR gate, the AND gate, okay, then NOT gate, then combination of logic gates. So that's all for the today. Thank you for your attention. Now we will solve some practice questions based on logic gates. Okay, so ready for the practice question, everyone? Yes or no? All right, please wait 2 minutes. Now students, we will solve some practice questions based on semiconductor electronics and logic gates, and this is part 2. All right, this is our disclaimer. Here we will solve some practice questions based on semiconductor electronics and logic gates part 2. All right, so our first question, the output of a two input OR gate is feed to a NOT gate. The new gate obtained is what? So students, the question says that the output of a two input OR gate is connected to a NOT gate. Alright, we need to find out what type of logic gate is formed by combining these two gates. Given options, option A OR gate, option B NOT gate, option C NOR gate, and option D NAND gate. So which option is correct? Please solve this question. This is a very simple question. Okay, please solve everyone. Which one is correct? Anyone? Yes. Option A, option B, option C, or option D. Which one is correct? Yes. Anyone? Please. Which one is correct? So the correct option is C. Alright. So look at here. A NOR gate is a NOR gate is a logic gate that combines the functions of an OR gate and a NOT gate. Okay. So first, an OR gate. The OR gate produce a high output if at least one of its input is high. Okay, then a NOT gate inverts the output, turning high into low and low into high. Okay, so when these two are combined in a NOR gate, the output is high only when all inputs are low. Otherwise output is low, and this makes the NOR gate a fundamental logic gate used in digital circuits. Okay, and this is the truth table. And for two inputs there is a four combinations: 0 0 0 1 1 0, okay, and 1 1, and this is the output for OR gate, and this is the output for NOR gate. Okay, second question: which of the following is a truth table for NOT gate? The question asks which of the given options is the truth table for a NOT gate. It provides four options, each showing a 2 cross 2 table. Okay, you need to identify the correct table that represents the NOT gate's output for all possible inputs. Okay, the NOT gate inverts the input. So if the inputs is 1, the output is 0, and if the inputs is 0, the output is 1. Okay, so please solve this question. Which one is correct? Option A, option B, option C, or option D? All right, please solve. Yes, Varsha, Karthik, which one is correct? So the correct option will be option C. Okay, so here a NOT gate is a basic logic gate that inverts the input signal. Its truth table shows all possible input and output combinations. Okay, so when input is 0, okay, the output is 1, and when the input is 1, the output is 0, and this gate is also called an inverter. It is essential for digital electronics and forms the basis for more complex logic circuits. Okay, next question. The output of OR gate is high. So the question is about an OR gate. It says that the output of an OR gate is high. You need to find out which condition makes the output high. So the options give different conditions for the inputs. Okay, you have to choose the correct condition that makes the OR gate output high. So given options: option A, if either or both the inputs are 1. Option B, only if both inputs are 1. Option C, if either inputs is 0. And option D, if both inputs are 0. So which option is correct? Please solve everyone. Which one is correct? So the correct option will be option A. Okay. So look at here. An OR gate is a logic gate, that produces a high input, high output. Okay. OR gate is a logic gate that produces a high output if any of its input are high. Okay. This means that even if just one input is high, the output will be high. Okay. The output is only low when all inputs are low. Okay. In simple terms, the OR gate follows the rule. If either input is high, the output is high. It is commonly used in digital circuits to combine multiple signals. Okay, so look at here. For two inputs, there are four combinations: 0, 0, 0, 1, 1, 0, 1, 1. Okay, and the output will be 0, 1, 1, 1. Okay, and their Boolean expression y equal to a plus b. Clear? Next question. To get an output 1 from the circuit as shown in the figure, the input must be what? So the question asks what input values will make the given logic gate circuit output 1. The figure shows a logic gate circuit with three inputs A, B and C. You need to find which combination of A, B and C from the given options will result in an output of 1. Given options: option A equal to 0, option B equal to 1, option C equal to 0, and option B, A equal to 1, B equal to 0, C equal to 0. Option C, A equal to 1, B equal to 0, C equal to 1. And option D, A equal to 1, B equal to 1, and C equal to 0. So which option is correct? Okay, this is a very simple question. Okay, please solve. Please use a smart work here. Okay, to find out the output. Okay, so when we solve this question by a smart work, look at here. This is AND gate. Okay, this is AND gate. Yes or no? And question ask about the uh, output should be 1. Okay, and what is the condition for output 1? All input should be 1. Yes or no? All input should be 1. It means what? C is equal to 1. Yes or no? So C is equal to 1. C equal to 0, C equal to 0, C equal to 0. Here C equal to 0. So C equal to 1 in option C. Okay, so C option is correct. Okay, C option is correct. Clear? Let's see solution. So this is the solution by a Boolean expression. Y equal to A plus B dot C means Y is true only when either A or B is true. Okay. So in the truth table, we see that Y is 1 only in the cases where A or B is 1 and C is 1. For example, when A equal to 1, B equal to 0, okay, and C equal to 1. Look at here, this one. A equal to 1, B equal to 0, okay, and C equal to 1. Okay, this one. The expression evaluates to 1. Alright. Hence A equal to 1, B equal to 0, and C equal to 1. Clear? Next question. Digital circuit can be made by the repetitive use of what? The question asks which logic gate can be used repeatedly to make a digital circuit. It provides four options: option A, OR gates; option B, AND gates; option C, NOT gates; and option D, NAND gates. So which one is correct? Please solve this question, everyone. This is a very simple question. Alright. Which one is correct? Please solve. So the correct option will be option D. Let's see the solution. So repetitive use of NAND and NOR gates allows the creation of various digital circuits. Okay, so these gates are fundamental because they can be used to build all other logic gates. So by combining multiple NAND or NOR gates, complex circuits like adders, flip-flops, and memory units can be designed. So this makes NAND gate and NOR gates essential in digital electronics. They are simply circuit design and are widely used in integrated circuits. Alright, next question. The following truth table is for what? So the question gives a truth table with inputs A and B and output Y. It asks you to identify which logic gates corresponds to the given truth table. You are provided with four options. Option A, NAND gate, option B, AND gate, option C, XOR, and option D, NOT gate. So which option is correct? Please solve. Please solve this question, everyone. Which one is correct? So the correct option will be option A. Okay. Look at here. Here, a NAND gate is this is the symbol of NAND gate, and this is their truth table. So we can say a NAND gate is a logic gate that produces an output of 0 only when both inputs are 1. Okay. Otherwise, it outputs are 1. So the output Y is the negation of the AND operation between A and between inputs A and B. Okay, so this is expressed as Y equal to A dot B complement, where the bar over A dot B indicates the NOT operation. Okay, so if A and B are both 1, so Y becomes 0. So in all other cases, Y is 1. Yes or no? NAND gates are fundamental in digital electronics and are used to build more complex circuits. Clear? Next question. Which of the following is the truth table for the digital below? Which of the following is the truth table for the circuit below? Okay. So there is a circuit. This one you have to find out the which one is the truth table, correct truth table. Okay. So the question asks you to identify the correct truth table for a given logic circuit. All right. So you need to determine which option matches the behavior of the circuit. All right. So the correct option will be option A. So look at here. This is the uh, NAND gate. So we know NAND gate produces the opposite of AND gate when both inputs are the same, A and A. Okay. So the AND output is A when input is high. So output is low when input is low. Okay. Output is high in NAND gate. So the NAND gate NAND output is the negation of this. So y equal to a dot a complement. So using the De Morgan's law, the this becomes a complement plus a complement. This one, which simplifies to a complement. So a NAND gate which both inputs connected to the same signal, a outputs inverse of a. All right. Next question. The circuit as shown in the figure will act as what? So the question asks what type of logic gate the given circuit in the figure acts as. It provides a diagram of a circuit and four options. Option A, OR gate, option B, AND gate, option C, XOR gate, and option D, none of these. So which one is correct? Please solve everyone. Please solve. So the correct option will be A. Okay. So we know in the given circuit, look at here, the circuit, output Y prime will come from NOR gate. A and B are inputs and NOR gate combines A and B. So Y prime equal to A plus B whole bar. After this inverter is attached to this NOR gate. Okay, so output Y equal to Y bar, Y prime bar. Okay, so Y equal to Y prime bar means A plus B double bar. Y equal to A plus B. The same output comes from OR gate. Okay, A plus B double complement is equal to same. Yes or no? So we will get A plus B. Okay. Next question. The circuit as shown will act as. The question shows a circuit diagram and asks what type of logic gates it represents. Okay, it gives four options: option A AND gate, option B OR gate, option C NAND gate, and option D NOR gate. So which one is correct? Please solve. Everyone. So the correct option will be A. Okay. So look at here. This is the truth table. Two inputs A and B. Two inputs A and B. Then in inverter inverts the two inputs A and B. Then NOR gate combines the two inverted inputs. Truth table is shown here. Okay. So a bar is inverted of A and B bar is inverted of B. Then NOR gate combines the two inverted outputs and complement it. So final output becomes Y equal to A bar plus B bar whole bar. So the truth table shows the corresponding values of inputs and outputs. Okay. So the output of two NOT gate A is input for NOT gate. Okay. So from De Morgan's law, Y equal to A bar plus B bar, or A which is equal to A double bar dot B double bar from De Morgan's theorem. So it is equal to A dot B with same results one could obtain from AND gate. Okay. Next question. The circuit is equivalent to what? So the question asks you to identify which logic gate are the given circuit is equivalent to. It provides a circuit diagram and four options. Option A AND gate, option B NAND gate, option C NOR gate, and option D OR gate. So which option is correct? Please solve everyone. So the correct option will be C. Okay. So we have two inputs A and B and a circuit made of three logic gates connected one after another. So the NOR gate takes the inputs A and B. It first does an OR operation A plus B where plus means OR, then it inverts that result. That little bar on the top means invert the result. So the output of NOR gate, call it y1 is y1 equal to a1 a plus b whole bar. This means not A or B. Okay. So output of NAND gate. Okay, so the NAND gate takes two inputs. Here both its inputs are connected to the same signal Y1, the output of the NOR gate. Okay, and NAND does an AND operation of these inputs and then inverts the result. Since both inputs are the same, Y1 and Y1, the AND of Y1 and Y1 is just Y1 itself. Okay, so Y1 dot Y1 complement is equal to what? Think about it. So Y2 will be A plus B complement dot A plus B complement and then whole complement. All right. So it will be Y2 equal to A plus B which is equal to A plus B. All right. So output of NOT gate Y equal to Y2 complement. So it will be A plus B complement. Clear? So which is output of NOT gate. Clear? So that's all for the today. Thank you for your attention. Okay. So in tomorrow uh, is All India mock test. Okay. So you need to join. Okay, everyone. So that's all for today. Thank you for your attention. Best of luck for the exam. If you have any doubt, please ask. Okay. Thank you for your attention. Thank you.